This conference will now be recorded.
Okay, so the question is, what is services? So guys, do you have any idea about the load balancers? Correct, all of you?
Yes. Distribute
Yes,
the
sir.
traffic between the servers.
Yeah, load balancers means basically there is one machine, there is a server, there's a VM, there's one applications which you install. Load balancers, the job is to load balancer is to just to transfer the traffic. Okay, there's a few algorithms are also there. I am not getting into that, but transferring the traffic, not holding the traffic, just route the traffic to the randomly to someone or maybe specific server or something like that. So that way that all the loads can be balanced. All the loads should not come on the only one, only one node. So it should be balanced. So that is a load balancer. Now there is a primarily two kind of load balancer. Nowadays is coming a little few more, but not complicating this topic. One is a network load balancer, and another one is which one?
Application load balancer.
So network load, which one?
Application load balancer.
This okay, application load balancer, correct. So application load balancer. Now there's a just take a note of it. This is assignment for you. Each one of you have to write today, end of the day, what is the difference between the networking load balancer and application load balancer, and just understand the technical aspects of it, so it will help you. So now next thing is, we got a network load balancer, we got application load balancer. Now network load balancer, the moment we see that, we hear it, then we understand that okay, this balancing is happening at the network level, IP address level. So that is easy to understand. Application load balancer, I would like you to give me that region for it. What is application load balancer? What are the technical specifications for it and all stuff like that. So today I'm talking about network load balancer. Okay, so network load balancer. Now when I say network load balancer, that means in Kubernetes we must be having some sort of API resources for it, right? And that is where services is coming into the picture. So in Kubernetes you can get a network load balancer also, and you can get a application load balancer also, both. But I am teaching you network load balancer. This is the most important. Okay, there are more than 57 resources which we have. So which are the resources so far I have taught you so far? Any idea? Anyone would like to tell me?
Pod replication controller deployment.
Pod replication controller deployment. Few more?
Services.
No, I'm just discussing services. No, I have not covered so far. What else? Yeah, so namespace we discussed, right? Namespace is also resources. Node also is a resources. Okay, so this is the service. So now network load balancing I'm teaching you today, and that is API services. So look at this image here. Okay, so how many nodes we have? 6 nodes. Forget about the master concept here. See, master is needed for managing the cluster, but ultimately the application is running in the worker node, right? So here if you see this image, very simple image, you have 6 nodes, and then you have each node you have a pod. Now what is a pod? We have already spent a good amount of time on it, And here we have a pod and which we have IP address, which is the IP address. And then we have some of the pod is database, some of the pods front-end pod and stuff like that. So database pod and front-end pod. So these are the two types of pods are there. Now you know the deployment and replication controller, correct? All of you remember that, right?
Yeah.
Remember that, right? So deployment and replication controller, deployment, so the pod get disappeared because of any number of regions. So immediately replacement pod is getting replaced, correct? Now you saw that. So IP address will change again. Here you see there's a front end pod, there's a back end pod, IP address also of the pod, and all stuff like that. So are you comfortable with this image so far?
Yes, the database pod IP has been changing.
Yes, I mean it will change. No, the let's say you some of the pod get say destroy. So a new pod will be replaced in some of the worker. So IP address automatically will change. Correct, no? So now the problem is, think about the internal communication. The problem is which front end pod will talk to which back end pod. There is a confusion. So there's a confusion. You can replace the pod with the virtual machines also, no problem. Concepts are same actually. Okay, pod also run your application. Virtual machines also you run your applications. So here from the front end pod to the back end pod, if you see the communications, which one I should configure in the front end? Should I configure the first one or should I configure the second one? If I configure the first one, all the loads will go to the first one. If I configure the second one, then all the loads will go to the second one. Again, if I configured one, maybe that pod is getting deleted or destroyed because of some reason. So IP address will change. Are you seeing the problems here? All of you?
Yes, no single point of contact to reach out to the front end. It is being changed every time.
Yeah, yeah. So what is the solution for this problem? What is the solution for this problem?
Load balancing service.
Load balancing. Yeah. So you see that again, what you did the rollout process. Yesterday, I have given you the task to the rollout, right? So you did the rollout process and initially you deployed the V1 of your software. Now you have a V2 also. So two version of software is running in your cluster, two deployment. So now the problem here is, should I transfer to V1 or should I transfer to V2? Okay, so this kind of problems you may have in the Kubernetes, and the solution is service. So now you see that all the front end talking to the service, and service has a specific DNS entry in the cluster and IP address as well. And now service will decide whether it should transfer the traffic from the front end to DV1 or V1 or V2. I mean, first database or second database. Yeah, just give me 2 seconds, guys.
This conference will now be recorded.
Hello.
Yes, yes.
Yes.
Hello. Am I audible, guys? Hello.
Yes, DP, yes, DP.
Yeah.
Yeah,
So
I
yeah,
think like Rajesh was telling something and I'm not able to hear. It's okay.
yeah. Sorry. Yeah. So here we are talking about the service. So now you see that all the traffic from the pod will go to the service, and service will decide whether it should go to the DB1 or database 1 and database 2. So now you understand that in a simple way, if I say, if you want to load balance the pod inside a cluster, mind it here, inside a cluster, then what you need to create, you need to create a service. So this part is clear for all of us, right?
Yeah, Rajesh.
Yeah. So now next thing, you must be having a question like how basically this works, how this service works. This is important. Okay, so let's continue the slides. So see here, uh, here you have a 2 pod, then you may have a 2000 pod also. That will be load balanced by the service, and accordingly the traffic will manage. Now there is one problem here. So the problem is I want to transfer the traffic to the pod which is 1.2 version. So when you have a 2 deployments, actually Apache, I mean your app 1 version 1 and version 2, so you want to either direct to the version 1 or either you want to direct the version 2. Okay, so this is something which we have, so version 1 and version 2. So how do we manage this? So that is where the label works. So what is a label? Anyone have idea what is a label?
Basically tags.
Yeah, so you guys have worked with the labels or not? All of you?
Yeah, like actually we have worked right, so the labels.
Yeah. Correct. So I with intention I said modify the labels of pod, modify the labels of deployment and all. Have you done it right? All of you?
Yes.
All of
Yeah,
you?
Raj-
Yeah. So that is a very important concept, guys. See, creating a service is just a 2 commands I'll tell you, and you will be able to create a service. That's not a challenge. The challenge is how it works. When you start troubleshooting, when you design your own application, that is where that this information needed. So how this label works? So look at this here. Here we have one service and labeled with a prod B 1.3, and then we have a multiple pods also. So here we have a pod with labeled with a prod B and 1.3, pod B 1.3. So that you need to hear this statement from me. Okay. If the labels of pod matches with the labels of service, labels of pod matches with the labels of service. So those pods which is matching with the labels of service, those pods can be load balanced by the service. Are you getting my points? All of you?
yeah, Raj-
Yeah. So if the labels of pod matches with the labels of service, that means those pod will be load balanced by service. That's all. Very simple statement. Are you understanding?
Yes.
No, Rajesh,
Yeah,
can you
Rajesh.
explain again?
Sorry, anyone is having question?
Yes, can you explain again?
I am saying very simple statement. You in a cluster, you may have a thousands of pod, and you may have a multiple service also. So now the question is, which service will load balance which pod? Very simple. Which service will load balance which pod? The relationship is very simple. The labels of pod, if matches with the labels of service, those pod will be load balanced by service. Are you comfortable so far?
Yeah, got it.
Simple. So in that case, if you see that the labels of pod is matching with the service level, correct now? So these three pods will be load balanced by this service. So this labeling can be done manually also. You have done it already. How to do that? Using commands also. Many ways are there. Don't worry about those. Understand the concept. By the way, you tell me your observation, and this I would like to know from you. And that is, did I get the right labeling or not? This is the right labeling or not?
Manifest files can mention,
What is that?
for pod manifest file you can mention
No, my question is very simple. Did I did the right labeling in this situation or not?
no.
Why? Why?
If hundreds of pods, how to labeling for every pod? It is wasting of time.
Why
No.
these two
Anyone
pods have
else?
the same? I have a question here. So why the two pods have the same IP address? Hello, am I audible?
11311. Yeah, yeah. Yes, I can hear you. Can you hear me?
Yeah, I can hear you. So why
Yeah,
these two pods have the same IP address? Is that so? I
yeah.
mean,
This is a good note. Good notice actually. But this is the mistake actually. So the IP
okay,
address should not be same. So yeah.
yeah,
But apart from that, tell me one thing. This IP address should be different. Okay, pod will have a different.
right,
So
right.
now the question which I'm saying, did we do the right labeling or not?
Uh, should the labeling be have any syntax, Rajesh? I mean, syntax with respect to something like
No, logical thinking.
some.
See, understand this way.
Service
Service
should have
will load balance the pod. Huh?
service should have the
Anyone?
three of service should have the three only one of the three labels so that it can able to uh, pick the common ones in both that and it able to coordinate. If at all it is three, so it cannot decide all the three different labels are being.
No, those aspects are okay. And those aspects are okay. Okay, so no one is noticing actually. I'll tell you in a simple way. Tell me how would you feel if we, first time what will happen when you type a www.devopsschool.com/login. This is the URL. Same URL. URL is same. Okay. And first time you will go to the login page. Wonderful. Behavior are correct. You log in. But the moment next users, what they will do, same URL they'll go and hit to the registration page. Same URL. And third user will come and same URL and they'll go to the dashboard. Would you accept? URL is same by the way, but first time you are seeing the login, so second time you seeing the registration, third time you are seeing what is it, dashboard. Would you accept this responsibility behavior?
No,
So did you notice that what is happening here? Did you notice, all of you, what is happening here? No one is noticing.
Didn't get the point, Rajesh.
I said very simple statement. I said one URL, one user is hitting, same URL, you are getting login page. Same URL, second user is hitting, getting a registration page. Same URL, third people are hitting and getting a dashboard. My questions to you is very simple. Would you accept this behavior?
Two
Yes.
different of DBs
Yes.
here.
No,
Like
No.
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 Why?
No. See,
If
if
you are
you access the
logging
Facebook
into, yeah,
if you access the
continue, Rajesh.
Facebook, yeah, if you access the facebook.com and let's say I'll load the twitter.com, will you accept it? You're accessing the login page, so you should get login page. Everyone should get a login page, not a registration page. Same URL, I repeat. Correct now? So did you notice something here which is wrong? Anyone?
The auth and DB having same tags or
Yeah.
label.
So see that, see when you load balance, very simple fundamental. When you load balance, you should have a similar applications. So here the pod DB is okay. Second pod DB is also okay. Third pod which has a auth container is not okay. That means what will happen when I hit the service first time, it will take me to the DV1 pod, then second also DV, third one auth. So what was the mistake? Who did the mistake? Tell me. Who did them? Because I told you very simple statement. The moment the label of service, the moment of label of pod is matches with the labels of service, those pod will be load balanced. So here is matching is happening. That means these three pod will be load balanced by the service. Are you understanding, all of you?
Rajesh, one question.
Yeah.
Mostly the service is meant for triggering the request to different containers, right? That means pods to serve the service depending
Yes.
upon the application serving inside the container.
Mhm.
And here you are being contradictory telling that you are being connected to the database. Usually we do not expose our database to the internet.
See, my topic is different here. All I am asking is here, look at this. Front end need to talk to the database. So for that, you need a load balancer of what? Database, correct? Na? Service you need for database, na?
Yes.
Correct? So here we understand how this label works. I mean, service works. So I'm saying the moment the labels are matching, those pods will be load balanced service. All I am asking is the logic. Did I label right or wrong? Did I label right or wrong?
So Rajesh,
I
you mean
think
to say that the
So
same type of pods. That means whatever the applications are running inside the pod should be similar so that we can label it, right? And that will be coming into one.
yeah, yeah. So this is our mistake actually. So this is our mistake. If you see that here, just a second, guys. I think I closed this. So here this is the what mistake we have. Very simple. Not sure why you are not able to observe. See here, traffic is coming to here. Agree with me so far? Correct?
Yes.
And then it will first time it will go here. Second time it will go here. Third time it will go here. See this service. What was service? So DV service, correct? So you should have a DV here also, and here you should be having DV, but you have auth. Why this mistake has happened? That's what I'm trying to tell you. Why? Because I labeled it and match with the service, the DB service. So who did the mistake? Are you understanding all of it? Who did the mistake?
Labels.
No, you did the mistake. I did the mistake. I labeled this pod also and this pod also with the same label. System works in a certain ways, right? We did the mistake. I should have not done this and this. All of you are clear? So because service will load balance only those pod. See, there's a more pod here, more pod. But this service will not balance this pod. Why? Because label has to match. If it's not matching, then it will not load balance. But here in this case, I labeled the auth also with the same pod label number, same label. So now service will load balance, but it's a wrong labeling, right? Make sense, all of you? Understood?
Yeah, right.
Yeah.
So that's what I was saying. If you log into the one website, you are supposed to get login page, not a registration page. Here, what you are happening? There's only one service. Behavior are changing every third transaction. One is okay. Second user is okay. Third user is getting problem. Fourth user is okay. Fifth is okay. Sixth is a problem. Correct now? He was expecting database sixth user and third user, but he got authentications. Correct now? All of you?
Yeah,
So this is the service, guys. So now I will explain you a little bit more into this. And okay, let's do one thing. Let's not complicate furthermore. I will share that after the few demos. That will be easier. So now you have understood. Let me create a service. So for that, I have a T and
So Rajesh, I have a small question. So
yeah.
the load balancing, you mean to say that it is going to be happen with all services?
Yeah, service is a
Only.
load balancer only.
So so if it is such like that, do I have more than one services in the load balancing, or only one service at a time?
You can have as many service, 100 service, free of cost. I'll create in front of you.
Okay,
It's a free
so
service.
if there are n number of services in the load balancing, so then for the next service, the next pod can be attached, right? I mean, for the next service, next labeling pod will be attached. Similarly, something like
I'll do that in front of you. I'll do it. Yeah. I'll do in front of you. Are you able to hear me?
Yeah.
I'm just thinking. My folder was there, no? Okay, my folder and the load. Okay, no. Yeah. So guys, this is the CP pod 1. Okay, so you have a pod 1 and a pod 2. Okay, so pod 1 and pod 2. So vi pod 1.yaml. Oh, I don't want this. I want some web-based application so I can show the results. So CP pod 1 pod. So vi pod 1. Now this is the v1 image. Correct? Now all of you are able to see my screen, right? Hello?
Rajesh.
Yeah, Rajesh.
Hello?
Yes.
Yeah. And this is the v2. So I'll just change the name v2. Why? Because this image I'm using for the training purpose. I have this image on the hub.docker. v1 and v2. In the deployment also we used it last day. So right now kubectl apply. First let me see what we have. So get pods. Oh, many people are running. Just a second. In the you should not run in the deployment, guys. Durga and Sri, you run in the default. We should not do that because
Yeah.
each one of us will have our own namespace. So I'm cleaning up a little bit for my work. Okay, so kubectl get pods -n Rajesh. So I have one deployment. Let me delete this. So I'll just show you the clean demo. Delete. Deploy -Rajesh and delete pod and this one also. So I'm deleting it. Time. Yeah. So guys, all of you see that there's no pod, right? Agree? So now kubectl apply -f pod1.yaml Rajesh and 2. So guys, here kubectl get pods -n Rajesh. So you know I made a mistake in the 2 actually. So let me delete this. Kubectl delete pod, name of the pod -n Rajesh. what mistake I did, I'll tell you. vi pod1.yaml. I'll change the name, which I did not. So I'll just make it very easy name, pod1. Okay, and then second one also, pod2. Pod2. Save it. Now I will do kubectl apply -f and -n Rajesh 1 2. So kubectl get pods -n Rajesh. So are you okay so far?
Yes.
All of you?
Yeah.
So guys, here show I created 2 pods. Why? Because see, theoretically what I'm trying to do. So here what I'm trying to do, I'm creating 1 pod and 2 pod, and then I'm creating 1 service here. Now what I'll do, I'll change the label of pod and this pod and this service. It should match. Okay, this should match. The moment it should match, this service will load balance this or this. That means if anyone hit to this service, it will traffic here or here. Make sense? All of you?
Yes.
Yes.
Now what I am doing, what I did, I created these 2 pods, but if I have a similar kind of pod now, then load balancing you will not be able to experience. It will happen, but you'll not be able to experience. So for that, what I did, I have 1 image here and second image I'm having. This is wrong practice. You should have both the places same image, but because I want to see, I want to experience the 2 different kind of container through the load balancing, I put it a v1 image, v2 image. Are you okay with that?
Yeah.
Hello? Wonderful.
Yes, Rajesh.
So now what I did, yeah. So here you have, see, this is the labels. Okay, so both the labels are okay right now. Initially we gave it. Now I'll create a service. How do I create a service? So kubectl create. Now the problem here is I forgot the command. So if I forgot the command, what should I do? Tell me. Remember?
Hit help.
Help.
Hmm. Now here you have a service itself is a 4 types. I'm not complicating right now, don't get loose. So they'll say, hey Rajesh, service you have a 4 types, which one you want? Whether you want cluster IP or external name or load balancer or not. I'll explain it to you, don't worry about that. Right now this is the default, so I'll go with the default. So here I'll put this and then again -h cluster IP. Now I got a lots of idea, lots of examples and all, and I will do this. So now we need to understand this code, right? So Kubernetes 3. So this code. So kubectl create service clustered IP. This one. So here this is the command. This is the type of service, and this is the name of the service. Now this one you will understand better. So 5678 is a service port and 80 is a container port. Okay, container or port you can say. Service port means, see here. So 60, and there should be some port number here, right? And here also there's some port number. So that is what exactly that we are saying. 5, 6, 7, 8. And always I use my namespace. Clear the screen. First I'll see that do we have any service in my namespace. There's no service. I will do the CRUD. I think you know very well CRUD means what. So created. See, the service is ready. So you have a service. What is IP address? So IP address of service is this one and this one. Okay. So this is the service. Now this service you can describe and see all command, you know that. Okay. So same command svc and this one. So here you have IPs. Okay. So, and this service is load balancing the pod or not. So here you have target port. Target. So sorry, not target port, endpoint. My bad. So what was that IP address I used? Oh, I used this one. Now let me create one more service. CS1. This time 80 because my container is running on 80 port, no? So
Space missing.
Space between 80 and -n.
okay. Clear the screen. See. New. So this one you should check endpoint. Remember that any service, when you want to see how many load balancer this service is doing, so you should check that. So guys, this is a labels of pod. And this is the label of service. Tell me, is it matching? And this is the describe. New one I'm using, okay? So tell me, what should I do? This is the label of pod. This is the label of service. And if I see the endpoints, there's no load balancing happening. So what should I do? Tell me. All of you. Any
Create
idea?
load balancer between these lines.
Which one?
Create
What
load
is that?
balancer these two pods.
There is no connectivity between the node and the pod.
Node and pod, why we are discussing all this stuff? I'm saying that what is missing. Remember the theory part. Actually, I explained you. I'm a little slow today. There is a reason why. Usually, I'm not slow. I teach very fast, but it's just like a little bit of feverish I'm feeling. So, but still, you guys are not telling me the right answer. What should I do? Tell me. So I told you, right? How this, understand? Tell me one person how this service works. I told you very straightforward statement. How the service works.
Using labels.
Labels.
Labels were
So
not
tell me,
matching.
this so
Not
this is the labels of service not matching right now. Not
yes.
matching, correct?
Yes.
Yes.
Okay. Yeah. So simple. What to do? Match the label. Simple. So go to the my CS new, and I will add app is equal to hello world. Here is my CS new. No, I will add hello world. Let me do that. So I'm editing this new
You can
one.
edit this.
I can edit pod also, no problem. But I feel I editing service because 2 times I have to modify pod. Where is the labels? Here it is. Hello world. Sorry, I think it was same line. Hello world. So now save it. Now let me check. Get pods. Get SVC. So now it's matching or not?
Match.
So this is matching. This is matching. Correct now? All of you?
Yeah, Rajesh.
Let me see the service now. Describe the service. See the endpoints. So here the service labels are matching of the 2 pod, and this is the one. So here endpoints you have 0. Hello. So endpoint is coming nothing. Endpoint is coming nothing.
I think it should match both the labels so that it can able to fetch.
Huh. So guys, did you understand that?
It needs to match both the labels, I think, so that it can able to connect to that pod.
No, 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 no. Actually, you know what? I told you wrong things.
Selector.
I told you wrong things. I taught you wrong things. Yes. So far you reached successfully. Good. But the one statement which I made, actually, that was wrong. What was wrong? So I told you, I told you, I told you, I told you, if the labels of pod matching with the labels of service, okay, then load balancing should happen. That means the service should load balance. But you know what? Actually, the statement is, please hear me out and look at this one. If the labels of selector of the pod, understand that, if the labels of the pod must match with the selector label of the service, then load balancing should happen. Are you understanding me?
Yeah, like in the sense
Did you
like the
understand that?
selector is like we need to connect to the image, right? Selector will use.
Huh.
Hello.
So selector is something like, you know what? Selector is something like, so service saying, hey, service, I'm a service. Service saying, I'm a service. I will select the pod, but which one? I will select the pod which is matching to this one. Got it? Hello?
Yeah, got it, Rajesh. Yeah.
Hello, guys. So I
Yeah,
taught you wrong thing. Now let's correct this. So here what I'm saying, I don't care this label and pod label. There's no relationship between the pod label and service label. There is a relationship between the selector label of service with the pod label. So now I'll do the final changes, editing the service, and here I'm just for surety I'm modifying this label, adding one, but here selector label I'm modifying the hello world. See the magic, hello world. Correct now spelling, and now describing the, did you see the magic now? All of you?
Yes.
Yeah.
yeah, Rajesh.
Yeah.
See that here, endpoints. So now this service is load balancing two pod. Can we test this? So service IP address, this one, curl http and done, and port number, what is the service port number? I forgot actually.
56878.
5678. Now see here, see here v2, but you know I can't visualize the load balancing, so let me run continuously. Yes, just give me 1 second, guys. Yeah, so just look at this now, output of this. Are you seeing the load balancing between the two pods? All of you?
Yeah,
Hello?
Raj.
So this is a load balancing. So let's conclude the discussion, guys. So load balancing is nothing but a networking load balancing in Kubernetes. Why we use services? Services we use for the load balancing, but for what? Pod. So you can create as many services load balancer free of cost. This is a free of cost. Okay, don't get don't have to pay anything because Kubernetes is free. Now load balancing is happening for the pod. Services is used for the load balancing the pod, and how it works. So if the moment the labels of pod matching with the selector labels, then load balancing happens. Labels of pod matching with the selector label, then load balancing happen. And this is how you can create a service. But if you're thinking like I am going to match the labels manually and this, that and all, don't worry about it. There's a command for it which automate the system. So everything can be done with the 2 commands, but I drag this topic because I wanted you to understand how it works. That's all of you understood, right?
Yeah, Rajesh.
All of you?
Yes.
Okay, so now I'm giving you the notes, guys. Same command I run it, and you have to try this one. After that I'll teach you the types of load balancer. Okay, so this is the IP address here. This is the master one, and worker one, this one, and I'm updating the same access you have actually. There's no change in access. So notes. I'm adding cube 3. Will that be okay?
Rajesh.
Yeah. So guys, I have added the notes now. So it's your time. I'll give you 20 minutes. Will that be okay for all of you? After that, I'll give you the crash demo for the remaining features also. Go ahead. It's your time now.
First
This
service
conference will now
that
be
is
recorded.
from the front end, right?
Yeah, tell me.
And front end service will
Yeah.
go and hit to the second service because he has to connect to the database.
Yes. Yeah. No. See that I'm drawing this picture. Okay. Please see this.
No, this
From
picture I got the idea. My only doubt is the first service, which is relating to the front end. After the front end access, it should hit to the database, right? And the database service is service 2. So
okay,
the
let
service
me
1,
draw the picture. I will hit the front end service. Okay.
yes,
Front end
yes,
service will redirect to the back end pod as a front end pod. Okay, front end pod I say.
right.
This service. This pod will go to the backend service, and backend service will go to the backend pod. This is what I'm doing.
Yeah, got it.
Okay, so are you comfortable with this image, all of you? All of you?
Yes.
Yes.
Okay, so if you're comfortable with all this, then if I'm outside, what to do? Because understand this service and this service, both service, the scope of this service is local. Local means cluster level. So now if you remember, I showed you Ubuntu so here
Rajesh, a small request. Yeah, please change the size.
Yeah.
Okay.
So if you remember that kubectl create service -h. See, these are the type of service, right? So what is this service called? So if you see that here, this service, the one which I created, this service which I want to created, actually the service, the one I created is a clustered IP service. Okay, so this is I'm putting up. This is a clustered IP service. So this is a default service. Default service. Now this accessible only inside, accessible in cluster only. That is a thing. It's accessible inside a cluster only. And if you see that image, this service, both are clustered IP service. Let me show you here. kubectl get svc -n Rajesh. See here. Type, what is that? Clustered IP, clustered IP. Okay. So that is the stuff. Understood, all of you?
Yes, sir.
Yes.
Yeah. So now cluster IP, cluster IP. Now, what is the then this type which is node port? So you should give me answer, okay? So this guy is okay. This guy is happy. This guy is happy because he can access that service directly. But what about this guy? What about this guy? Tell me.
We can
Can
attach
he
an external
access this front-end service? Can
we
he
can
access
attach
this external service? No. What is that?
I think a port should be opened for
Can
the
he access this
cluster.
service?
no.
No, but the here, here this IP, I'll put it in simple way. Okay, you answer me. Let's say Johnson, are you there in this call?
I'm here.
Yeah. So Johnson, you and me are staying in the same apartment. You are my neighbor, I am your neighbor. You are also having Wi-Fi, your own, and I'm also having Wi-Fi, my own. So from my machine, can I ping to your machine two different Wi-Fi, two different network?
No.
Can I? No. Why no?
Without authentication.
Authentication will not come. No. Reachability. See, authentication authorization comes when you have a reach. I'm not able to reach. First of all.
Yes. Got it.
Correct now? I'll not be able to. Why? Because the scope of your network is local. You are not allowing the port forwarding. So what will happen? This guy also, any service, any pod, which is not accessible from outside. So by the way, anyone remember what I did with the pod? I forgot actually. Anyone have a good memory? What we did with the pod when we wanted to access from outside?
We have given the cluster IP, no forwarded the
No.
port forwarding. Yesterday we have done.
Port forwarding. Yes, we did know yesterday. So pod was not accessible from outside. This guy, put it that this guy. Okay. So what we did, we added the port forwarding features, and then that pod was accessible at where? At where? I repeat, at where?
From outside.
No, at where?
Your question was not clear, Rajesh.
No, I said you access the pod at where? What was the IP address for accessing the pod after the port forwarding?
We have accessed the virtual machines
Machine
IP
map,
address.
public IP.
IP address of node, correct? Worker
Yes.
node or master node. Node IP. Just say node IP. Correct now?
Yes.
Yes.
Not a pod IP, node IP. So what happened? The pod, what has happened last day? Pod got exposed at the node IP, and this guy can access the node. Simple. Correct now? So something similar we have to do today also. So this service, you know what? This service is accessible only inside a cluster. So that is the reason we call it a clustered IP service. But you know what? This particular service, the moment we expose the service, we expose at the node port. Yes, pod can be exposed, service can be exposed. So the moment this service can be exposed at this node port, then what can happen? This guy, if the firewall is allowed, this guy can hit the IP address of this. Possible or not?
Yes, possible.
So now the question was, what is a node port then? So node port, what happens? You get a clustered IP. You know, in a node port, you get a clustered IP service, and plus service get exposed at node port, each node port. So that is called node port. How do we create it? Let me create it in front of you. So here the command which we ran last time, here create service, here clustered IP to node port. So I repeat, node port will create a clustered IP service only exposing will happen at the node port. So here node port, and this is the one and all. So restart 12 sudo -s. So kubectl get svc -n Rajesh. See here guys, look at this very carefully. This is a node port, type is node port, but you got a clustered IP also, and this is a service port, internally service port for this, and a node port, the IP address of node, and this is the port number 31239. So that means you have a cluster IP also, and which is exposed at the node port also. Are you understanding, all of you?
Yes.
Yes,
All
Rajesh.
of you?
That means we can
So
able to
what to
access
do?
from within the cluster as well as outside the cluster, right? Both way possible.
Only if you expose the service. If you have a type node port, that means this service which you created, which is exposed at the node port. So now I can access. Let me show you. So first let me change the label, selector labels. Edit. NBC. Edit SVC. MyNP. And where's the cluster label? Hello world. Which was a port, right? Describe this. I'll just check this. Describe SVC. See that true port has come. It can be 2000 also. And now IP address of this is curl. Internally, I'm from inside, okay? And the port number internal one is this one. See that? Now from outside, this is the port number. And what is the IP address of the node? This is the one. Any one node you can use it, okay? Any one nodes. And port number is 312539. So I got V2. I put this URL in the chat window. Confirm me if anyone got the V1. Try this out. Anyone got the V1? Anyone?
Yes, I
No.
got V1. Yes, I got V1.
Wonderful. Wonderful. So this is the stuff. So now see, this guy is also happy now because this service we expose the every port of the node. Now next thing is see who is always budging the IP address. No one. So what to do? So that is where, see, there's a two node, right? So what to do? So here we'll plan some load balancer at the node level. See, this service inside, it was balancing the pod, but we need external load balancer like AWS or Azure or something like that. And this load balancer will balance the node because that is managed by AWS. So this can be done third way. And now people will hit the load balancer. So load balancer is only one point. So you see that full traffic. This guy will hit the load balancer, one IP address. From here, it will go to the node port. from this front end services, from the front end services, front end pod, from front end pod to the back end services, and back end services to back end pod. Did you understand the whole relationship? All of you?
Yes.
Okay. But who's hitting the load balancer? Have you hit this load balancer? No. Then we'll keep the DNS server here. DNS server is route 53 or something. So DNS server like a www.devopsschool.com. So anyone hit the devopsschool.com, it will redirect the DNS servers to this IP address, and from here we discuss that. So here the question is, what is the load balancer type? So this load balancer type is nothing but this one. So basically what happens in the load balancer, you get the service created. You get a service created. Okay. After that, get exposed at node portals. At node portals. That means node port is being done. And then plus it create a load balancer at AWS or Google Cloud or something like that, or Azure, and add each node to this load balancer. So when you select this one, then this will happen. But now it will not work because my cluster has no idea about the AWS, So this is the stuff. Did you understand, all of you, what is the service concept?
Yeah, Raj.
All of you?
Yeah, Rajesh.
Yes, Rajesh.
Great. So guys, so far this was the planned agenda which I planned for covering it. So let me recap the stuff. First thing, I taught you what is Kubernetes. Then why Kubernetes? Then we discussed on the architecture side of the Kubernetes. Then we set up a cluster on the Kubernetes. After that, started understanding the different commands and different utilities and all, different API resources and all. So some of the API resources which we discussed, which include node, namespace, pod, replication controller, replica set, deployment, and services. So these are the foundation services which we have, and slowly, you can get into that and then start working. Got it, all of you?